Assalamualaikum and hello everyone. So in this video, what we look at for the PSPM is K0 to 6. Still going to look at section A. For the question 2, 3 and 4, remember 2 hydrocarbon, 3 is between hydroalkene and hydroxy. Number 4, carbonyl and carboxylic acid. But this time around, we're going to look at for the question for the year of 2014 and 15. Okay, so here let's look for question number 2. So question number 2 is mostly our chapter 12 question. Okay, so dekat sini dia minta arrange the following alkanes in order of increasing boiling point. So here is quite straightforward. Okay, but remember that increasing boiling point. So for example, for a given structure, what you have to do is actually jangan kamu tengok jangan tengok pada nama sahaja. So you have to draw the structure itself. Okay, why? Because when we will compare the molecule, we're going to look at the size. First and foremost pada size dia lah. So contohnya kat sini kita tengok nonane. So nonane maknanya we have 9 carbon. So contohnya here we have 2244 tetramethyl pentane. So if you look at the parent name, memang ada pentane. It's 5. It's 5 here kan? But then based on the name, pada carbon number 2 ada 2 of our methyl, number 4 pun ada 2 of our methyl. So when I count the number of the carbon itself, 1 2 3 4 5 6 7 8 9. So masih lagi 9 carbon. So that's why first and foremost, before you're going to compare this one, draw the structure first. So when you draw the structure, then you can count how many carbon. So for example, if all the structure has the same number of carbon, next you're going to look at is the branch. Okay, so what's the effect of the size? Kalau size ni is basically we're going to look at the number of carbon itself lah. So contohnya kalau size dia, if the size is bigger, then our boiling point is higher. Tapi kalau branch pula, branch ataupun the other name is actually when we have multiple substitute ataupun substituent. Ini beza pula. Kalau branch kita banyak, so kita punya boiling point it will be lower. So dia adalah opposite one. So if you be unsure, tengok balik pada nota chapter 12 kamu, 12.1. Okay, and then question B dengan C is basically adalah reaction here propane. Yang ni adalah 2-methyl pentane. So this is the reaction of our alkane. So kalau alkane, for the chemical reaction dia memang sikit sahaja, which is halogenation dengan combustion. Is this two only. Sebab alkane itself is saturated compound, so it's very stable. So dia tak undergo many reaction lah. So yang ini adalah monobromination, where we're gonna write down the mechanism. Tapi dekat sini dia bagi tahu write the chemical equation and determine the major product. Remember yang pasal yang tertiary is more stable, secondary more stable dan primary. So boleh tengok balik nota chapter 12 kamu, 12.1. Sebab when you determine the major, barulah kamu boleh jawab number 3 ni. Dia minta mechanism for the formation of the major product. And then the question C is actually our combustion in excess and limited oxygen. So yang ni I believe you could do it yourself. So question number 3. Question number 3 is basically our haloalkene. Haloalkene RX kita dengan our alcohol. Chapter 14 dengan 15. Okay, so number 3A ni dia bagi tahu kita this table shows the relative rate of SN2 for alkyl halide. Alkyl halide ni sama lah juga dengan kita punya haloalkene. So it's the same thing lah. Okay, so dia bagi dekat sini adalah relative rate. So what does it mean relative rate? Adalah maknanya what is the rate of reaction bila this bromomethane undergo SN2. Okay, so that is the what is meant by the relative rate ni lah. So let's look for the question itself. We have 1 until 4 ni, tapi I'm going to discuss 1 until 3 sahaja. Okay, so for the SN2 reaction, sebenarnya it prefer for methyl dengan primary. So that's why lah bila kita tengok relative rate dia is quite high lah untuk methyl dengan primary haloalkene. So maknanya kalau value dia high, maksud dia naklah SN2 reaction. Okay, so dia bagi tahu dekat sini, explain the relationship between the class of alkyl halide with the relative rate. Okay, so kita akan bagi tahu sebenarnya the rate of the reaction. Okay, sebab kata relative kan, kita tulis balik. The relative rate of reaction is higher from primary ataupun nak buat methyl halide pun boleh compared to the tertiary alkyl halide. So as you can see, macam makin ke bawah ni value dia will be lower. So as you can see, maknanya kalau primary ni lagi is faster than our tertiary lah. Okay, so that's for question number 1. Question number 2, give one example of compound A. So here is my compound A, which is secondary carbon. Now secondary haloalkane. So and then dia bagi kat sini a 4 carbon alkyl halide. So I draw it 1, 2, 3, 4 carbon here. Lepas tu bila kita ada 1, 2, 3, 4 carbon. Okay, if I draw the bromine at the end here. So nanti dia jadi primary pula. So there's only one choices here if we drew it in the middle here. B kat sini boleh, kat sini pun boleh. And then we're gonna name it. Walaupun tak minta, kita bagi sajalah nama dia, which is 2-bromobutane. Okay, and then question 3. Sebenarnya kat ABC ni 1, 2, 3 sebenarnya. Okay, question 3, dia kata predict the value of B and give your reason. So this is the value of B. So kita nampak sebenarnya makin ke bawah ni the value is lower. So bila value makin lower, when value dia makin lama is smaller, it means that it does not want to undergo SN2 mechanism. So kalau tertiary ni, so ikut kamu lah nak bagi certain value ke apa, tapi selamatnya kita cakap lah it will not be higher than 0.03. Sebab makin lama makin ni value dia ke bawah ni makin kurang kan. So the value will be less than 0.03. Okay, and dia minta give your reason. Okay, sebab that tertiary alkyl halide does not favor SN2. So kalau tertiary alkyl halide sebenarnya dia suka SN1 lagi. Okay, why? Due to the steric effect. So what is actually steric effect? So kita tengok balik nota chapter 14 kita. Okay, dekat sini. It's on page 6. So dekat sini, bila kita tengok SN2 mechanism, basically the mechanism is actually heavily based on the nucleophilic attack from the back. Kalau primary, kita mostly akan cakap yang carbocation kan. Tapi kalau for yang SN2 is the nucleophilic attack from the back. Okay, so kalau untuk kita punya SN2 dia prefer primary ataupun methyl halide. Sebab we do not have that many of our carbon group ataupun alkyl group. Okay, sebab contohnya why? Sebab apa ni? Bila kita ada banyak alkyl group dekat sini, susah nak nucleophilic attack from the back itself. So kalau primary ni kita nampak senang sebab hydrogen ni sebenarnya dah ambil space dia sikit saja. Steric ni sebenarnya maksud dia space lah. So bila primary ni it is deemed as easier sebab senang sikit. So contohnya kita tengok dekat sini kan. Ni nucleophilic attack kat sini lagi senang for our primary ni. It is easier compared to yang tertiary ni. Ni bayangkan contohnya kamu nak jumpa artis yang kamu sayang kan. Lepas tu kat sini banyak bodyguard yang besar-besar, tak sempat nak jumpa. Yang ini ada satu tapi pandailah kamu menyelit kan. So macam tu lah sebenarnya. For SN1 it prefer methyl ataupun primary. Sebab tak adanya apa ni presence of many alkyl group. Sebab the presence of alkyl group ni susah lah. We want to make to do the nucleophilic attack from the back. Tapi ataupun senangnya nak simplenya nak cakap sebenarnya it's based on the steric effect. Maksud dia adalah kalau CH3 ni, our tertiary ni dia ambil banyak space. So that's why kita kata ni adalah steric effect. So susah sikit lah nak nucleophilic attack from the back for our tertiary. And sebenarnya secondary pun susah juga. Okay, so ataupun nak simplify kan, tulis je lah dekat sini. Tertiary alkyl halide does not favor SN2 due to our steric effect. Okay, so that's for question A. Okay, question 3A. Tengok balik. Okay, so ni question B. Consider the following reaction. So it's from alkene akan form kita punya alcohol. So what is the reaction from alkene to alcohol? Tengok balik nota chapter 12 kita. So nota chapter 12 kita my map alkene. So from our alkene, from our alkene nak jadi alcohol. So where's our alcohol? So tengok dekat sini, kita akan form yang alcohol dekat sini lah. So yang ini bisa tolong juga ni. Banyak juga sebenarnya Miss tolong tapi tak apa. Okay, so suggest one possible alkene to produce F and give the suitable reagent. Lepas tu dia minta chemical test to differentiate 1-pentanol to pentanol dengan F. So this is actually all your chemical test. So you have to do the equation and the observation for each of the equation. So that's for question number 3. So now let's look for question number 4. Okay, cuma question number 4 ni tolong betulkan. This is actually not the questions. Ni dengan ni sama saja. A dengan D ni sama saja kan. So question number 4 ni dia nak suggest suitable reagent for the conversion of butanal. So what is butanal? Butanal is our aldehyde. Aldehyde yang ada 4 carbon for the following compound. So usually dia bagi reagent nak produk kan, ni terbalik pula. Dia dah bagi dia dah bagi reactant, dah bagi produk, minta reagent kita. So butanal is our aldehyde. So tengoklah nota chapter 16 kita kan, nak tengok mind map kita yang ini. Mana aldehyde so tengok balik nota aldehyde kita, mind map aldehyde kita. Okay, so macam mana nak convert the aldehyde to our 1-butanol ni adalah alcohol. And then what is the reagent to convert our aldehyde to butanoic acid, which is our COOH. So this is 1 mark, 1 mark. So question B, yang ini tricky sikit. Show the synthetic step for the preparation of isopropyl cyclopentane from propanol via Grignard reagent. So it's a 6 mark question. So sebenarnya soalan ni tricky, so sini Miss tolong. So kita tengok pada solution here. Okay, so what do we want is that dia bagi kita nak prepare from propanol. Propanol ni is actually our ketone. So kalau ketone ni C double bond O, dia punya bodyguard both ni must be carbon. So bila kita tengok sini 1, 2, 3. So we have already our 3 carbon kan. So this is our propanol and this is the skeletal structure. Okay, so dia nak kita prepare kan from propanol ni dengan Grignard reagent, kita nak form isopropyl cyclopentane. So isopropyl cyclopentane is actually our cyclopentane. Lepas tu ada ekor ikan. Okay, so this is actually our isopropyl lah. So dia bagi kita macam mana form this reaction, nak form this reaction. Tiba. So dia memang pelik sikit, tapi kita boleh je buat yang ni. Okay, so what happens is that sebab bila kita dah kata propanol via Grignard reagent, so maknanya kita akan reaktkan ketone kita ni dengan our Grignard reagent to form our alcohol. So memang first adalah kalau dengan react Grignard memang akan form alcohol lah. Okay, tapi macam mana alcohol tu? Kita akan form alcohol dulu. Nanti baru kita fikir how to produce our alkane. This is actually our alkane. Macam mana nak buat alkane ni? Okay, so first and foremost, what I would like to do, sebab Miss nampak macam ni tau. So, bila dia dah double bond O dekat sini, Miss nampak macam, yang gini macam asalnya macam ni. So, kat sini dia bagi hint sikit, our Grignard reagent is actually our cyclopentane. So, Miss reaktkan Miss punya propanol ni dengan cyclopentane. Dengan cyclopentane, and then Grignard reagent kita tambahlah MgBr ataupun MgCl. Okay, and then actually how does this reaction occur? So, bila kita punya propanol ni, dia akan jadi apa? Double bond O ni akan jadi OH. Lepas tu, yang double bond tu dah tak ada kan? So, maknanya kita akan form one new bond. Kita akan form a new carbon-carbon bond. Tapi carbon ni adalah when we're gonna mix up with our Grignard reagent. Okay, so what does it mean? Okay, ni carbon A Miss kan? Metal ni Miss kekalkan sahaja. Double bond O ni akan jadi OH. So, here is my OH. Okay, lepas tu kita akan form a new carbon-carbon from our Grignard reagent kan? Okay, tapi kalau kita nak form a new bond ni, Grignard reagent tak nak dah. Sebab ni akan jadi our byproduct. So, pada carbon yang sama ni, I'm gonna, bonded to it is actually our cyclopentane. So, this is actually the answer. Ataupun, Miss nak buat dia cantik sikit. It's not necessarily cantik pun. Tapi sebenarnya Miss nak buat dia senang sikit nak form yang isopropyl kita ni. So, maknanya what I draw is actually pada carbon Miss mula draw dulu Miss punya cyclopentane. Okay, cyclopentane ni bonded to carbon A kan? So, Miss buatlah ni. This is actually my carbon A. My carbon A is bonded to one of my OH. Ni dah OH. And then bonded to two of my metal. So, it's actually the structure is the same. So, kenapa Miss buat ni? Sebab Miss nak senang sikit. Miss nak nampak macam mana nak form ni. Nanti kalau macam ni, kamu pelik. Macam mana nak form ni? Macam pelik je. Okay, so sekarang kita dapat alkohol. So, bila kita dah nampak ni, sebenarnya kamu dah boleh nampak lah sebenarnya dah boleh form dah alkane kita. Okay, so macam mana kita nak form alkane kita ni? Okay, so first adalah, pada alkohol tu, dia tak boleh jadi alkane terus. So, what I'm going to do adalah akan form alkene. So, yang ni kan reaction yang famous kan. Dehydration of alcohol, where we're going to remove H2O. Ataupun specifically, kita akan remove OH dengan hydrogen from our alcohol. Okay, so OH ni Miss dah buang. Miss tak buang memang satu je kat sini. Remove hydrogen tu from the next carbon. So, ni kan si OH kita kan. Okay, so I have 3 neighbor ni. Sini is primary. Dia punya neighbor to its downwards ni, to the right ni pun primary. Here to my left ni adalah tertiary. Okay, so ada 3 pilihan hydrogen that I can remove. But remember, kalau hydrogen dia ada pilihan lah. Kalau boleh nak remove yang tertiary lagi, more stable. So it means that I'm going to remove hydrogen from here. So when I remove this hydrogen and this OH, I'm going to form double bond here lah. So bond ni dah tak ada. Bond OH ni pun dah buang. Okay, so bila bond OH ni dah buang, hydrogen buang, barulah kita tambahkan double bond dekat sini. Okay, so that's why yang ini, dah OH buang ni sebab dia jadi macam ni pula lah. Sebab tu jadi macam ni. Okay, and then jangan lupa kat sini ada our double bond. But then, sini baru kita punya alkene. Belum habis lagi. Not yet finish. Sebab itulah soalan 6 markah. So, from our alkene itself, macam mana nak form alkene? Dia senang sahaja bila kita reaction dengan hydrogen in platinum. So, what happen is that this bond will break, akan tambah hydrogen here, hydrogen here. But then again, in the skeletal structure, hydrogen is not shown. So, this is the answer for question number 4B. So, kalau yang ni soalan memang tricky sikit. Tapi tak apa, tengok. And then, tengok pula. You can pause it here lah, lama sikit pun boleh. Okay, next question adalah question C. So, question C, dia kata methanoic acid is the only carboxylic acid that react with Tollens reagent and give your reason. Okay, state the observation and write the chemical equation involved. Okay, so walaupun dia minta give your reason yang ni, bila dia kata state the observation and write the chemical equation involved, is actually regarding our Tollens reagent. So, macam mana dengan Tollens reagent kita ni? Okay, so let's look here. Bila kita tengok dekat mind map kita, okay, mind map of carboxylic acid kita ni tak ada apa reaction of methanoic acid. Okay, so what we're gonna do adalah kita tengok balik pada nota chapter 17 kita. So, nota chapter 17 kita, we have our the last page 8 of your carboxylic acid. Yang last kali ni kata reducing properties of methanoic acid. So, dekat sini dia kata methanoic acid shows both properties of carboxylic acid and carbonyl. So, that's why bila dengan carbonyl ataupun specifically aldehyde, dia bolehlah undergo. So, methanoic acid shows the reducing properties with our oxidizing agent dengan Tollens reagent. Okay, so soalan minta equation kan. So, you're gonna write down the equation here. So, bila dia undergo oxidation, sebenarnya the hydrogen itself ni akan undergo, akan form O- lah. So, this is actually our answer. Okay, tapi bila dia tanya, okay, yang itu adalah equation kita kan. But then the question asks, give your reason. Okay, kenapa this methanoic acid can react with Tollens reagent? So, the answer is that, okay, ini jawapan dia. So, you have to write down lah. Methanoic acid shows both properties of carboxylic acid and aldehyde. Hence, lepas tu, ni first point. Second point is that methanoic acid shows the reducing properties in reaction with, dalam kes ni, Tollens reagent. Okay, so that's the last for PSPM 2014-15.